Ask ChatGPT to write you a poem about rain 10 times and you'll get 10 completely different poems. But ask it what 2 plus 2 is and you'll get 4 every single time. Same model, same everything. So what's actually going on? The answer comes down to 3 hidden knobs: temperature, top K, and top P. These control how creative or predictable an AI model behaves. And once you understand them, you'll have way more power over every AI tool you use. First, you need to know how a model picks its next word. It doesn't just predict one token, it calculates a probability for every single token in its vocabulary. For the prompt, the capital of France is blank. Paris gets 92%, gets 1.8%, and 50,000 other tokens share the scraps. Now let's talk about temperature. Think of it as the chaos dial. Low temperature, like 0 to 0.3, makes the model sharp and predictable. The high probability token dominates even more. High temperature above 1 flattens everything out, giving unlikely tokens a real chance to get picked. Here's the math in plain English. The adjusted probability equals the original probability raised to the power of 1 over temperature. At temperature 0.1, Paris gets 99.99%, basically guaranteed. At temperature 2, Paris drops to 72%, and random tokens suddenly have a real shot. Temperature equals 0 is a special case called greedy decoding. It always picks the highest probability token. Zero randomness. Every single run gives you the exact same output. This is what you want for factual questions and code generation. Next up, top K. This one's simple. Before sampling, you throw away everything except the top K tokens, then pick from those. Set top K to 3 and only Paris and survive. Everything else gets 0% chance. But here's the problem with top K: it's a fixed number no matter what. When the model is 99% sure, top K of 50 forces it to consider 49 garbage tokens. When it's genuinely torn between 200 good options, top K of 50 cuts off great candidates. It's just not flexible enough. That's where top P comes in, also called nucleus sampling. Instead of a fixed count, you set a cumulative probability threshold. Top P of 0.9 means keep adding tokens from highest to lowest until their combined probability hits 90%. Then cut everything else. Watch how top P adapts. For capital of France, Paris alone hits 92%, so only one token makes the cut. But for a good programming language is blank, it takes 8 different languages to reach 90%. Top P automatically adjusts to the model's confidence. That's why it's preferred over top K. These 3 knobs aren't mutually exclusive. They're applied in order. First, temperature reshapes the distribution. Then top K trims to a fixed count. Then top P trims by cumulative probability. Finally, one token gets sampled from whatever's left. Here are the practical settings I recommend. For code generation, use temperature 0, you want correctness. For customer support chatbots, try temperature 0.3 with top P 0.9, natural but controlled. For creative writing, go temperature 0.9 with top P 0.95, diverse and interesting. One gotcha that trips up engineers. Temperature 0 with GPT-4 sometimes gives different outputs across calls. Why? GPU floating point math isn't perfectly identical across different servers. Use the seed parameter to fix this. Set seed to any number and your results become reproducible. Let's recap. Temperature controls the chaos, 0 is robotic, above 1 is wild. Top K sets a hard limit on candidates, simple but rigid. Top P adapts to the model's confidence, the smart choice for most applications. Now you know exactly which knobs to turn and when. Go build something with it.